Today I'm going to explain a complete machine learning question step by step how a neural network classifies SMSs as spam or not. And not just theory, we'll actually solve it numerically using forward propagation and backward propagation. So here we have a mobile service provider that wants to classify messages using a neural network. We are given three input features, like as you can see, x1, x2, x3. These are the three input features, and the target output is 1 or 0, that is spam or not. And a neural network with 5 hidden neurons, like we are taking 5 hidden neurons. We will train this network using given data. So let me first show you the structure of the neural network. So as you can see here, we have input layer. I have taken here 2 hidden layers. Like this, we have 5 hidden layers in our question. And this is the output layer. Each neuron uses a sigmoid activation function. Before solving, let's understand the flow of the formula. First, we'll be calculating the hidden layer input, like z is equals to wx1 plus wx2 plus wx3, like this. We'll be using this. Then we will be applying the sigmoid. Like as you can see, h is equals to 1 upon 1 plus e to the power of minus z. Then the output layer input will be giving this, as we can get here, h1, h2, h3. We will be doing here, applying that h1, h2, h3 for v1, v2, v3, and we will be assuming a v1, v2, v3 as 0.1 initially. Like even the weights also we'll be assuming 0.1. Okay, so just we'll be assuming for the first iteration. And the fourth step will be the final output. As you can see, the y prediction will be getting by using the sigmoid function. Okay, y is equals to sigmoid of zy. So next we'll be finding the error of it. Here we'll be getting the minus t minus y. E is equals to 1 by 2 t minus y whole square. This y is taken from this particular fourth step. Okay, then back proportion. What is this? As dou y is equals to t minus y into 1 minus y into y. This thing we'll be doing back proportion. Then we'll be updating the weights. V is equals to v plus neta dou y into h. Okay, after that we'll be getting the hidden gradient. As you can see here, we'll be calculating the hidden gradient. Then we'll be updating the new weights. So this will be our flow of solving this question. So as I have told you, we initialize all the weights as 0.1 and v values as 0.1 initially, and neta also 0.1. Now we are taking the first row, that is 4, 2, 1. Okay, and the target that we got was 1. This is the output that we got firstly. So we'll be finding, after finding whether our prediction is right or not, we'll be seeing it. If not, we'll be updating the weights. Simple. So here, as you can see, we'll be initializing. After initializing, we'll be calculating the z. After z, we'll be taking for all 5 neurons, we'll be taking the same z because we have initialized the same weight. Okay, then the hidden layer, we'll be finding h. After finding h, we'll be considering the same h for all the 5 neurons. Okay, then apply the sigmoid. After getting this, we'll be going with output layer input. As I have told you in our formula flow, we'll be finding this zy to apply inside this. Okay, to find the y value. So y is equals to sigma of this one. This value is zy. Y is equals to sigma of zy. We'll be applying the same formula, that is this sigmoid formula. We'll be finding y. Okay, now y is 0.5. Actual target value was 1. That means this is 1 and this is 0.5. We did not match this. So what do we do is we find the error as we go, like step by step we'll be going. We'll be finding the error, and then we'll be finding the output layer gradient. We'll continue to find all the steps as we have discussed, like update output weights, like this formula. After this, we'll be taking v's as same for all the 5 neurons. Then we'll be finding the hidden layer gradient as in the formula. After that, what do we do is we update weights. Why do we update weights? Because whatever the value, y value that we got was not matching with the target. As you can see here, like the target was 1 and the y value that we got was 0.5. So in case of this, we have to update our weights. We'll be updating weights for all the 3x values. All the features, we'll be updating the weights. Okay. After that, the first row is completed. Now, after first iteration, the y value was this, and the new weights, or whatever the new weights were, these are the 3 new weights. Since it is a spam, okay, it is a spam because it is greater than 0.5. Okay, that is it. And for next row, it is like x is equals to 1 0 1, and the target value we have 0, and same steps will be continuing with the new weights as we have got updated our weights, and the same steps will be going on. As you can see, vi is also changed. Why? Because here updated vi we got 0.1067, right? So we'll be considering that for the next iteration, right? Neta is same as 0.1, as you can see, and the same steps will be repeated. First you find the z, then you take it for the all the neurons, and then find the hidden layer, that is h, then consider it for all the 5 neurons, and then zy you'll be finding. After that you will be doing this y is equals to sigma of zy, and then you will be finding error. After that, output gradient, then you will update your v update. After updating, you'll be finding the hidden gradient. Now you'll be checking whether the y value that you got, what it is, you got 0.5 and the target was 0, right? It is not matching. 0 and 0.5 are not matching. What you do is you just update the weights again. You update input weights again, w1 w2 w3. You find the 3 new weights and also the hidden output. You will be finding, you will be taking it, and you will be doing for next iteration same thing. After updating weights, updating vi, then hidden gradient, these are the updated weights. Like that you'll be finding for another iteration also. Okay, another iteration is like row 3, that is 6 comma 3 comma 1. As you can see, we have 4 rows. 6 comma 3 comma 1 is the third row. So you'll be taking the third row and you'll be doing the same things for this thing. Okay, this is about the single neural networks. As you can see here, we have gone through the same steps that we have told. Like you can see it here, these are the steps that we have gone through. Completely 8 steps. Single neural networks. We have taken 5 hidden layers, so we have found it.